Hello and welcome to the AvCam podcast. I'm Sarah Taylor, Digital Content Manager at Avalanche Canada, and I'm your host for today's episode. We're being joined today by Simon Horton, who's an Avalanche forecaster and our research officer here at AvCam. Simon's one of our most experienced forecasters and has lots of practice with wrangling today's topic, weather forecasting. Thanks for joining us, Simon.
Hi, thanks, Sarah.
So let's start off with, how does the weather impact the avalanche conditions?
So weather's really paramount in forming avalanche conditions. It does a couple things. First off, it puts the snow on the ground in the first place. So really how we get a snowpack and layers in the snow is all based on what the weather's doing over the season. Then on any given day, the types of avalanches we could expect are really dependent on what the weather is like that day.
And so as the weather changes, do we expect that to change the avalanche danger too?
Absolutely. And it happens on different timescales. Over the courses of weeks and months, we can have stormy periods or dry periods, and that will form the layers and that'll have impacts. And then on the short time scales, like a sudden change in the weather, like heavy snowfall, wind, or change in temperatures could dramatically change the conditions.
That all makes sense. So how simple is it to predict the weather for the mountains?
Well, to be honest, modern days, like on the phones, you get pretty good weather forecasts just with any generic app. It's a really hard thing to forecast the weather. The atmosphere is large, complex, chaotic. There's whole bodies of research groups who spend millions or probably billions of dollars figuring out how to forecast weather better. And you get pretty good information for free. But also, if you like to spend time outside and in the mountains, it's often worth your effort to get a bit better at learning about weather and practice over time and learn more of the details and nuances.
And that's a process that takes a while, right? Where would you start out with that? How would you begin to start digging in?
Oh, yeah. Any kind of backcountry activity, it takes time and experience to really get good at. You need practice. Meteorologists often call it both an art and a science. And so the science is you need some basic understanding of the processes of how weather happens, or in the avalanche world, how avalanches form. But to really get good and experienced at it, it's through pattern recognition and recognizing over a long period of time how different things play out, because really there's some general rules of physics it follows, but it's too complex to be prescriptive with how weather plays out. So there's a lot of art and pattern recognition to it.
Totally. And I think there's a good point there in that weather forecasting is definitely a science, and there's definitely some firm facts to it, but also sometimes the forecasts don't play out the way that we think they're going to, even when we've followed all of those patterns and we know what we think is coming. So what stage in your daily process do you start thinking about the weather? Yeah,
so really for any kind of outdoor activity, weather's often the starting point, probably even before avalanches. In many cases, you want to, a few days out, if you have the opportunity to do an outdoor activity, you want to start looking at the weather and just getting a kind of general sense. So there's a fair bit that goes in before the trip, kind of from the kind of longer range up to before you're heading out the door, having a bit of an understanding and preparing your trip to be appropriate for the weather. And when you're out, you want to verify the conditions. So it's really quite similar to the daily process that we teach in avalanche courses, where you have a structure to how you plan a safe trip in the backcountry. Almost at all the steps where you're planning for avalanches, weather is really right there as well.
And you mentioned that verifying conditions in the field. What kind of things are you going to be looking at in terms of avalanches once you're in the field when we think about weather?
Well, when we're talking about verifying the conditions, most avalanche forecasts are written a day in advance. So there's definitely some uncertainty when we're writing a forecast as to how exactly what will be the weather the following day and how that impacts conditions. So you can do some quick verification kind of before you're actually outside by checking for nearby weather stations, webcams. A lot of ski hills have both of that, like a weather station and a webcam, so you can get a sense of what's actually happening. And then once you're actually out kind of traveling in the mountains, it's really good to pay attention to changes in the weather. So typically, it's the main weather drivers that drive avalanche hazard. So there's precipitation, wind, temperature, and sky cover. And these are all things that are really clearly articulated in avalanche forecasts in the weather summary. As an avalanche forecaster, we really try to dial down what these 4 things are going to look like that day. And our forecast that we're making, like down to the danger rating, is really hinging on these elements being accurate. So that's why it's important to verify, because as I'm sure anyone who's been out before, both the weather and avalanche conditions can be different from what you expect.
If you're finding, for example, more precipitation than you thought you were going to see, that's going to be a clue that you should be changing your plans, right?
Yeah, certainly. Yeah, it can happen where you find locally conditions that are different from what the forecast said. So yeah, amount of snowfall, sign or major signs of like wind loading, with the snow's really warming up and you're feeling, the heat on your face and snow dripping off the trees. These are all signs of that the weather is changing in a way that's more dangerous for avalanches.
Okay, so we've established then that the weather is really important and it's going to change the way we travel and what we plan, and how we can slot it into our planning. How can we start interpreting weather information?
So how do we get into this art of weather forecasting?
Yeah, exactly.
There's always more to learn about weather, no matter what you know. You can spend a lifetime learning about this art of pattern recognition. So, if you're starting with just typically looking at an app on your phone and getting a local forecast, how you could start moving and advancing that is using this concept that meteorologists use called the forecast funnel. And the idea there is, before really looking at the details of exactly what's happening where you are, kind of understand the state of the atmosphere by starting at looking at the big picture of what's happening in the atmosphere, and then gradually going down to smaller scales until you get to the local detail that you're at right there. And this approach will really help you get a broader sense of why the weather's happening and how it's going to change over time, because that forecast you just get at a point on your phone is just one guess from this very complex system. But these broader patterns in the funnel will really help you dial it in.
And how far out would you start looking at the weather before you were planning to get into the backcountry?
Well, this is always changing as computers and weather models get better. But in the ballpark, a week out, you can get an okay long-range forecast for the big picture. And by big picture, I'm talking about high pressure, low pressure systems. Is it generally going to be stormy? Or is it generally going to be fair weather? And when you look at this longer horizon, you're looking kind of at this big picture. And if you're in Western Canada, you're often looking at what's happening on the Pacific, because whatever's happening there will be moving its way, and in a few days will be impacting the weather where you are.
Yeah, so you're looking for those patterns and what's happening away, and then as they move in, that's going to tell you what's going to be coming for us next.
Yeah. So one of the main things you're looking at the big picture is for areas of high pressure and low pressure. In general terms, low pressure is where you have air rising, forming clouds, precipitation. High pressure, air is descending. It tends to be drier, clearer, calmer. And low pressure, as the main weather makers, can come in a couple of different flavors. They often have fronts with them, and fronts can really have distinct patterns in the weather. So when we're looking at the big picture, it's interesting to look at where there's high and low pressure systems and how they're moving. Are they moving from a warm part of the ocean, bringing warm, moist tropical air, or are they coming from the North Arctic, where it tends to be drier, colder? The kind of movement of these high and low pressure systems really influences the big picture weather pattern.
So if we do get that warm tropical air coming in, what kind of weather can we expect that to translate to for the mountains?
A source of the ocean with that moisture, when it hits the mountains, tends to create a lot of heavy precipitation. Warm air tends to hold more moisture. So we get a lot of precipitation, and in some cases, if it's warm enough, that'll come in the form of rain. So freezing levels are an interesting thing to look at in that scenario.
People nickname that the Pineapple Express, right?
And Pineapple Express, or atmospheric river, is a common term now used for those kind of weather systems that have the tropical origin. And really, all the different directions that weather systems can come from. The Northwest is another one where it's also coming off the ocean often, but it's colder, so it tends to be favorable for producing a lot of snow. If it's purely from the north coming towards Western Canada, it tends to be quite dry and cold.
All right, and where would you look for that data?
So compared to just getting that like local spot forecast on your phone, there aren't as many spot places to go to get really good information about the big picture. The best and most reliable is the mountain weather forecast on the Avalanche Canada page. That's produced in partnership with Environment Climate Change Canada. It's at avalanche.ca/weather. And that whole page is dedicated to really telling a story about the weather in terms of these big picture systems that are highs, lows, fronts, how they're moving, and how that's going to impact the mountain weather. There are some other spots you can find that kind of info, but it's rare to find. And I just really want to emphasize the value in looking at that information to see the big picture. It gives you the context of why you're going to experience the weather you are in your area. So after identifying the basic type of weather system, we're going to probably have questions now about specifics of precipitation, how much, when, how windy will it be, how warm or cold will it be, these kind of actual putting numbers to it to really help guide us in the understanding the local weather. And the best way to do that comes from using numeric weather prediction models. This is really the core of modern weather forecasting. And these are big supercomputer models that crunch the movement of air in the atmosphere. And there's actually not too many of them. They're so big and expensive to make or to run. They're really just run by a few government offices. And they make that data available. And so the thousands of different websites and apps you see out there to get weather are usually taking it from these handful of models and just presenting it in different ways. But these models, by calculating how the air is moving through the atmosphere, really give us the numbers that are core to our forecast.
I know there are lots of different kind of weather models. What kind of weather model would you look to use for what kind of situation?
Yeah, the main difference between weather models is their spatial resolution. So we have models with low resolution that tend to give you a long range forecast. This is really good for looking kind of out a week to see the general pattern in terms of the movement of these weather systems, highs and lows. And then as we get into smaller resolutions, the time horizon doesn't go out as far. It's typically only 1 or 2 days for what I would call a high resolution model. And these are the ones that tend to do better in the mountains because they're really thinking about how the air is moving through the terrain. And so these higher resolution models tend to be the ones that do best for getting us precipitation, wind, temperature in complex terrain.
So there's a bit of a trade-off. You can get that kind of big picture, rough idea, long range, but it doesn't give you the specifics, or you can have a more specific short range that's going to give you some better quality detail.
Exactly. And that is totally following the forecast funnel. We start with the big picture, what's happening roughly for like the next several days. And then as we get more local, small scale models, more current time, what's actually going to happen locally.
And where do you find these models? How do you get this information?
So they're really available in all the different weather apps out there. But there are a few specific ones that I'll recommend for people who are traveling in the mountains. I'll start with our own website, the Avalanche Canada Mountain Weather Forecast. Shows output from these models on various maps. So you can get maps of snowfall amounts in our different forecast regions, along with wind, temperature, these things. We also have what they're called mediograms, and these are graphs that show at a specific point the amount of precipitation, wind, temperature. These tend to be quite technical, though, and they're what we use as the forecasters to make our forecasts are these really technical charts that have a ton of detail. That can be a bit much if you're kind of new to looking at this. And that's where some sites such as SpotWX and windy.com do a really good job of making easy to understand graphics. On both of these, you can use a map to pick a location and then view the forecast from different weather models, kind of both long range, the short range, and make comparisons between the different models too, because you'll always see discrepancies.
If there is a discrepancy in those models, is there a good way to think about which one you should put more weight on? Or is it very much just a case of going in between and trying to even it out?
Discrepancies, for one, can tell you a bit about uncertainty. If the different models are thinking different things are going to happen there, it probably means there's some uncertainty in exactly how that weather system is going to interact with the terrain local to where you are. So that will make a flag to kind of be open to different possibilities if I was planning to go with then, and really count on that verification. I'd have less trust. When they're all agreeing, you can have more confidence. There's a lot of different preferences for individual weather models depending who you ask. Generally, good guidance is work with a high resolution model typically, and get familiar with how it performs and learn kind of what it's good and bad at, because no one model can do everything best. So rather than totally jumping around and having a scattered approach, getting familiar with one high resolution model that works well in your area is generally the best approach.
Yeah, and I guess that ties into what you said right at the start about how this is a process and it's an ongoing thing and it's something that you need to put a bit of work into to get really good at.
Yeah, and I'd like to make one other point on using these weather models. Generally, you're picking a single point in the mountains, and this can have a big impact on the data you see from that. And it's often good to look at multiple points in the area or even look at that data on a map, because all weather models aren't perfectly resolving patterns in the terrain. And so the point you're picking might happen to be at a low elevation instead of a mountaintop. And so by looking at a few points in the area, you're more likely to capture conditions that are happening in the mountains.
Yeah, so you'll get a good spread of different models and different outcomes and be able to put them together to get a really good, accurate picture of what's going on. I know you mentioned meteograms before. And on our Forecaster blog, we actually do have an introduction to meteograms. So if anyone's interested in learning how to read those meteograms at a simple level, that's at avalanche.ca too, under the resources tab.
Yeah, that's great to have that information there to kind of get familiar with them. And meteogram is just a fancy word for a graph. It's got time on the x-axis, and the y-axis would have all these variables we've been talking about: wind, precipitation. It's just a visual display of data.
I really appreciate your time here and you taking us through this, because I know weather is an endlessly complicated topic, and this has been a really good run through of what kind of things you look for. Do you have any last pieces of advice for people who are interested in learning more?
Yeah, I think a great way to get better at learning about weather and understanding it is following it on a regular basis. Something like the Mountain Weather Forecast blog that kind of talks about the general weather patterns, just quickly scanning it daily, like you might scan the sports section or scroll through the news. I know most people who do winter work in the mountains have that habit of just keeping on track of what the weather's doing. It really helps you understand these patterns, and it's useful also for planning and keeping track of avalanche conditions, because the two are so closely tied together.
Okay, well, thank you so much for joining us. We really appreciate you taking the time.
Yeah, thanks, Sarah. It's been great.
And thanks to those of you listening for joining us for today's episode. Don't forget to make sure you have the forecast. If you're heading into the mountains, you can get it at avalanche.ca or on the Avalanche Canada app. If you enjoyed this, you can find more episodes wherever you get your podcasts, or share it with a friend. If you have any questions about anything you've heard on this episode, you can get in touch with us at communications@avalanche.ca. We'd love to hear from you. Thanks for listening.